Read now MCQ number 15. Read it. Come on. According to Gauss law, phi equals to sigma q upon epsilon 0. Now inside the closed surface, what have they placed in the statement? Some electric dipole. Again, you know, for an electric dipole, there are two point charges of equal magnitude, but they are unlike charges. One is positive, another is negative. Positive charge is plus q, negative charge is minus q. Their summation would be 0. 0 upon epsilon 0 will be 0. Phi equals to 0. You got the reason from physics point of view. For a positive charge, electric flux is going away from it. For a negative charge, electric flux is towards it. So for a closed surface which encloses both the positive and negative charges of equal magnitude, it will so happen whatever is outgoing flux, same is incoming flux, the summation of which should be 0. Correct? Read now MCQ number 16. Read it? Look. Similar arrangement we had in one of the numericals where two identical metallic spheres were suspended with the help of two equally long strings from the same point of suspension, and then after, when equal charge was given to both the spheres, they started repelling each other, and then the angle between the strings was increasing, and at a particular value of that angle, the spheres had come to rest. Okay, that sort of situation we had seen. And in that situation, remember, when the sphere comes to rest under that equilibrium condition, whatever is the upward force, same is the downward force. Upward force is T cos theta at that time, where T is the tension produced in the string, and theta is the angle made by either string with the vertical. And that upward force should be equal to downward force. Downward force was nothing but the weight of the sphere, which is mass into gravitational acceleration. Correct? Fine. Now, right now the whole system is taken into that region where there is no gravitation. Correct? So it is taken in the absence of gravitational force. I mean, it is taken, the whole system is taken into that region where there is no gravitational field. When there is no gravitational field, naturally this gravitational acceleration will be 0. When this intensity of gravitational field is 0 at that time, when G is 0, this part will be 0. In short, T cos theta will be 0. When T cos theta is 0, cos theta must be 0 because tension produced in the string is not 0. When cos theta is 0, theta must be 90 degree. Correct? And tell me, what was that theta? Angle made by either string with the vertical. Now when the theta is 90, the right hand side string will appear like this. So that angle made by this string with this vertical will be 90 degree. Similarly, angle made by this left hand side string with this vertical will also be 90 degree. And tell me, when both the theta values are 90 degree each, at that time the spheres will be getting arranged along this horizontal line. And at that time, what will be the total distance between these two spheres? If the length of the string is L, then this is L, this is also L, L plus L will be 2L. So your answer is distance between two spheres, which is 2L. But right now length of the either string is 1 meter. So 2 into 1, that is 2 meter. So final answer is 2 meter. Got it? Right now they have asked the distance, but they may ask the tension produced in each string. I am showing you how to find out that. Let us see that thing in the extra point. Now in this string, at this end, the tension is produced this way. Correct? Which is counterbalanced by this force, which is electric force exerted by this sphere on this sphere. Because both of them are like charges, so they will repel each other, and that is the repulsive electric force Fe. This Fe balances this tension. Okay. Similarly, tension produced in this string at this end is like this, which is counterbalanced by this electric force exerted on this sphere by this sphere. Okay. So I mean to say, for each sphere, the tension is balanced by electric force. When tension is balanced by electric force, what is the value of electric force according to Coulomb's law? K into Q, that is KQ square upon R square. But mind well, R is distance between these two charged bodies, and distance between these two spheres, you can say it is 2L, correct? So this R is 2L. They may give you all these values, and they may ask you to find out this tension in this situation, okay? Mind well, this is true for this situation where the system is taken into that region which is devoid of gravitational field, okay? Read now MCQ number 17. Read it? Come on. We have some point charge, say capital Q, placed at point P, and now nearby that point we have considered some closed surface, correct? It might be having any shape, might be having any volume, no problem, but just make one point clear in your mind. This charge is not enclosed by this closed surface, it is outside the closed surface, okay, fine. Now what have they asked? Due to the presence of this charge, what is the electric flux linked with this closed surface? Let us find out according to Gauss law. Phi equals to sigma q upon epsilon 0. But tell me, what is sigma q? Amount of electric charge, I mean summation of, algebraic summation of electric charge is enclosed by given closed surface. But in this closed surface there are no charges, that's why this sigma q is right now 0. 0 upon epsilon 0 will be 0. So phi equals to 0. Now tell me, from physics point of view, you may surprise, you might be getting surprised that why, though electric charge is there, why there is no electric flux linked with this closed surface? I am showing you the reason for that. You may think of this charge as positive charge, at that time electric field lines will go away from it, correct, this way. And when they go away from it, then for this part of closed surface, it will so happen that flux is coming inside, and for this part electric flux is going outside. As I said earlier, incoming flux is to be taken negative and same amount of outgoing flux should be taken positive. Equal values, one is negative, one is positive, then total electric flux will be 0, correct? Fine. Suppose you are talking about this charge as negative charge, then the flux will come towards it. At that time, if the electric field lines are coming this way, then this part will have incoming flux and this part will have outgoing flux. Again, in that case also phi equals to 0. Got it? Read now statement of MCQ number 18. Read it? Come on. In the earlier theoretical discussion, I told you in one of the numericals as such, what was that fact? I told you to remember, whenever we place identical point charges at all the vertices of some regular polygon, then resultant electric field produced at the centroid is 0, correct? Right now let us place n number of point charges, n number of identical point charges at all n vertices of a regular polygon of n number of sides, then the resultant electric field should be 0, correct? This is the electric field due to first charge placed at first vertex, this is due to second charge placed at second vertex, and this is due to the last point charge placed at the last vertex, okay? Fine. Right now we have placed identical point charges at all the vertices among all the n vertices. At each vertex we have placed identical point charge. But in the statement what they have given, that out of a regular polygon of n number of sides or n number of vertices, they have placed only n minus 1 point charges at n minus 1 vertices. Then what is the resultant electric field produced by that sort of polygon at its centroid? Let us find out. before this, the previous charge you can consider, here order is n, so previous charge must have order n minus 1, correct. Now they have placed totally n minus 1 number of point charges. So let us find out resultant electric field produced out of this summation. Produce out of this summation, that resultant electric field I am showing by symbol vector E dash plus this vector as it is, and that equals to 0 vector, correct, fine. And now transfer this. When you transfer this from plus, it will become minus. This will give me resultant electric field produced by given polygon having n minus 1 point charges placed at n minus 1 vertices out of n vertices, and that is what I want to find out, but that is equal to minus of vector E n. Just take magnitude. When you take magnitude, E dash will be equal to E n, but this E n means what? Magnitude of electric field produced by single point charge placed at nth vertex, means by single point charge. What is electric field due to single point charge? K into charge upon distance square, K into charge upon distance square, got it? Fine. Come on now, please read the statement of MCQ number 19. Have you read it? Look. Magnitude of Coulombian force exerted between two stationary point charges Q1 and Q2 separated by distance r is F equals to K Q1 Q2 upon r square, correct? Which are the two charges given to you? One is 2Q, another is minus Q, but here there are magnitudes. So you must write magnitudes of two given charges. One is 2Q, another is minus Q, its magnitude is Q, correct? So what is this now? 2kq square upon r square, 2kq square upon r square, okay, fine. Now what is done? That two identical spheres, one is having charge 2q, another is having charge minus q, they are brought in contact with each other through a conducting wire. So now there will be exchange of electric charge, but ultimately when you cut off that charge in the final condition, what will happen? Both the identical spheres will have equal charge equal to summation divided by 2. What is the summation of two charges? One is 2q, another is minus q, summation divided by 2. Whenever two identical spheres are brought in physical contact and then after when they are separated, the equal magnitude of electric charge on both of them will be summation divided by 2, correct? Fine. Summation of these two divided by 2, and let it be q1 dash and q2 dash, that is equal charge finally on first and second sphere, correct? Fine. Now these values are summation divided by 2, 2q minus q, that is q by 2, fine. Now what is done? That again both the spheres are kept at the same previous distance. Then what is the new Coulombian force? That is what we have to find out. Let it be F dash, which is K q1 dash into q2 dash upon r square. Why I am not writing r dash? Because final separation is same as initial separation between the two spheres. So earlier also was this distance was r, and now also distance is r. Now this K as it is, what is q1 dash and q2 dash? Both of them are q by 2. Both of them are q by 2 each, and upon r square. So now this is 1 upon 2 to the 4 into kq square upon r square. 1 upon 4 into kq square upon r square. But can't you find out kq square upon r square from here? Find it out. Kq square upon r square will be f by 2. Kq square upon r square is f by 2. This 1 upon 4 as it is, okay? So altogether it is f upon 4 to the 8. So new value of Coulombian force will be, come on, 8th part of initial Coulombian force. Got it? Fine. Kindly read the statement of MCQ number 20. Read it? Come on. My dears, here according to me, the question is wrong from physics point of view. What have they asked? Number of electric field lines coming out of 1 coulomb point charge. It is very wrong to ask this way, because electric field lines on one side we say they are imaginary, and on other side they are asking the number of electric field lines. The things which are imaginary, how can you find its number? We cannot find. Secondly, if it is only electric field lines, the number, in the textbook they have written that number of electric field lines itself is known as electric flux. Again, it is not true, because number does not have any unit, whereas electric flux has the unit. Okay? So they should not have asked the same question this way. They want to ask actually amount of electric flux coming out of that positive charge. So what should have they asked? Find out the amount of electric flux coming out of 1 coulomb positive charge. Okay? And that too they have given the value of epsilon 0. So indirectly they want to say that that charge is placed in vacuum. Let us find out now. Wherever that charge is located in vacuum, surrounding to that charge, we should consider some closed surface which can enclose that given charge. Okay? Now for that closed surface, what is the amount of electric flux? The same amount of electric flux is coming out of that positive charge. Let us find out that. Come on. Phi equals to Q upon epsilon 0 according to Gauss law, correct? Where phi is the electric flux which we require, Q is the given charge which is enclosed by considered Gaussian surface, which is closed surface. That charge is 1 coulomb. And what about epsilon 0? Permittivity of vacuum, it is 8.85 into 10 raised to minus 12 coulomb square upon Newton meter square. If you simplify, answer is 1.13 into 10 raised to 11 Newton meter square upon coulomb. Once again I am telling you that number of electric field lines linked with given surface itself is not an electric flux. If that number is greater, electric flux is more. If that number is less, electric flux is less. So electric flux is nothing but it gives us measure of number of electric field lines associated with a given surface. But that number itself is not flux. Had it been flux, then number does not have any unit, then flux should not have any unit, but electric flux has this unit. Okay, please. And second thing, electric field lines are imaginary. You cannot count the number of imaginary things. Okay. MCQ number 21. Kindly read the statement. Read it. Come on. Whenever any electrically neutral body loses certain number of electrons, means it loses certain amount of negative charge. So naturally it will attain positive charge. Resultant charge on that body will be in the form of positive charge. If positive charge of one proton is E and there are n number of protons, then you can think of total charge, that is n into E, correct? Whichever number of electrons are lost by neutral body, same number of protons will have its positive charge attributed to that body. So positive charge gained by the body after losing certain number of electrons would be Q equals to n into E, correct? Where n is the number of electrons lost, which in this case they have given 10 raised to 19. What about magnitude of charge of electron or charge of proton? It is 1.6 into 10 raised to minus 19 coulomb. Now this 10 raised to plus 19, 10 raised to minus 19 will cancel, giving you final answer plus 1.6 coulomb. Naturally, when electrically neutral body loses negative charge, it must gain positive charge, correct? Fine. Read now MCQ number 22. Read it? Come on. We have one simple cube having 6 identical faces. Which 6 faces? I am showing you. Top, bottom, front, rear, right, left. Which 6 faces? I repeat, top, bottom, front, rear, right, left. Got it? Fine. At the centroid of which there is a positive point charge, say plus Q. Okay. Now tell me, surrounding to this positive charge, it has its own electric field away from it. Correct? So you can think of electric field lines going away from this positive charge. And when those electric field lines are going away from this positive charge, naturally that total number of electric field lines will get associated with all the 6 faces, and that too equally, because the position of this charge is symmetric as compared to any face. In comparison with any face, the position of this charge is quite symmetric. Whatever is the distance of this point charge from this right hand side face, same is the perpendicular distance of this charge from this left hand side face, same is the perpendicular distance from front side, same from rear side, same from right side, same from left side, same from top side, same from bottom side. Correct? So the position of this charge is quite symmetrical as seen from all the faces. Okay, fine. Now the total electric flux is suppose 5, which is linked with all the 6 faces, and according to Gauss law it is charge enclosed divided by epsilon 0, that is Q upon epsilon 0. Correct? Here I am writing number of identical symmetric faces, which is 6, and total electric flux linked with all the 6 faces is Q upon epsilon 0. Q upon epsilon 0. With identical 6 faces, if this much total electric flux is linked, then in the statement they have asked electric flux linked with only one phase. So with one phase it is how much? This into this upon this. This into this means Q upon epsilon 0 upon this, that is upon 6. That's why I am writing here Q upon 6 epsilon 0. Q upon 6 epsilon 0. That is 6th part of total electric flux. 6th part of total electric flux. Got it? Fine. Read now statement of MCQ number 23. Read it? Come on. We have one liquid drop having mass m and having charge q, which remains suspended in air under equilibrium, that is, it remains steady. Then you must say that its downward weight must have been balanced by some counter force. Now what can be that counter force? Here they have given charge, they are asking about magnitude of electric field. So there must be, in the same region, there must be some electric field which exerts electric force in vertically upward direction, which balances this downward gravitational force. Correct? On a body of mass m, what is downward gravitational force? Mg. And on a charge q, what is electric force? Charge into electric field. Both these forces must be opposite in directions, then only they can cancel the effect of each other, then only this liquid drop can remain under equilibrium. Correct? Fine. So in order to have equilibrium condition of this drop, we can say Mg must be equal to QE. Oppositely directed forces must have equal magnitudes. Come on, Mg must be equal to QE. When Mg equals to QE, they have asked about strength of electric field. Find out capitally from here. It is Mg upon Q. Mg upon Q. Got it? Can we read now statement of MCQ number 24. Read it? Come on. We have one closed surface in which there is electric dipole having two unlike charges of equal magnitudes, one is plus q, another is minus q. And now they have asked resultant or total electric flux linked with this closed surface. According to Gauss law, phi equals to sigma q upon epsilon 0. Sigma q means algebraic summation of charges enclosed. One is plus q, another is minus q. Summation would be 0 upon epsilon 0 will be 0. Let me remind you why total electric flux is 0. Because for a positive charge, electric flux is going out, away from it. And for a negative charge, electric flux is coming inside, that is towards this negative charge. But here, magnitudes of these two charges are equal, and hence, whatever is outgoing flux, same is incoming flux, and hence their summation is 0. Correct? Incoming flux is to be taken negative, outgoing flux is to be taken positive. When charge is positive, this electric flux is positive. When charge is negative, electric flux is negative. Correct? For a positive charge, flux is going outside. For a negative charge, flux is coming inside. That's why I am saying outgoing flux is to be taken positive, incoming flux is to be taken negative. Kindly read now statement of MCQ number 25. Read it? Come on. In the figure along with the statement, they have shown half of some cylinder, say right half, and at the edge of the cylinder, they have given one positive point charge, say Q. Fine. Now they have asked, due to the presence of this point charge, what is the electric flux linked with this half of the cylinder? In order to find out the answer, what we just imagine, the identical half of this cylinder, identical half, not better half, okay. You can think of mirror image of this part taken on this side, it will be like this. This extra half cylinder is imagined by us, it is not given to you, but we can imagine, okay. Now if you combinedly think of these two half cylinders, then it forms one closed cylindrical surface, okay. And for this closed cylindrical surface, this charge is placed at its centroid, and hence the total electric flux linked with entire cylinder, if it is phi, then just electric flux linked with only half of that complete cylinder will be phi by 2. If phi is the total electric flux linked with entire cylinder, then electric flux linked with right hand side half of the cylinder will be phi by 2. Correct? Now tell me 1 by 2 into phi, but phi is how much? Come on, according to Gauss law, it should be Q upon epsilon 0. Correct? If it is complete cylinder, then total electric flux is 5, but right now only half of that cylinder is given to you, and hence the flux is half of 5, that is 1 by 2 into 5, but 5 is Q upon epsilon 0. Ultimately answer is Q upon 2 epsilon 0. Q upon 2 epsilon 0. Correct? Same amount of electric flux will be with left half of the cylinder also, and altogether it will make the flux Q upon epsilon 0. Got it? Fine. Now my dears, we begin with section D. In the textbook, after MCQs, they have given a list of certain short questions, out of which some question answers we have not discussed so far. Majority of the questions given in that list we have discussed in the theoretical part, in the numerical so far, but those questions whose answers are so far not discussed, I would like to accommodate them in this section, section D, that is belonging to short questions, okay. But we will just select only those short questions whose answers are not so far discussed, okay. Kindly read the statement of first short question. Read it? Come on. What is the charge of one proton, that is E, and total charge of n number of protons will be n into E. Now this total charge given to you is 1 microcoulomb, but 1 microcoulomb you may convert into coulomb, multiply by 10 raised to minus 6. This number of protons equivalent to this much charge we have to find out, and charge of one proton is 1.6 into 10 raised to minus 19 coulomb, correct? Find out value of n from here, you will get 6.25 into 10 raised to 12, that many protons, okay? Read now number 2. Read it? Look, we have two spheres, one has two identical spheres, but one has charge of 1000 electrons, another has charge of 600 protons. Come on, when you bring them in physical contact and when you separate them, the equal charge on both the spheres would be summation divided by 2. Come on, charge of 1000 electrons will be 1000 into minus E, because charge of 1 electron is minus E. Charge of 600 protons will be 600 into plus E, because charge of 1 proton is plus E. And summation divided by 2, correct? Come on, this is minus 1000 E and plus 600 E, altogether it will be minus 400 E, or you may write 400 into minus E upon 2. 400 upon 2, that is 200 into minus E. What does minus indicate? Charge of 1 electron, and such how many electrons are there? 200. So on the surfaces of both the spheres in the final condition, the charge will be of 200 number of electrons, correct? Fine. Read down number 3. Read it? What have they given? If product Q1 into Q2 is greater than 0, then what will be the type of electric force between them? Will it be attractive or repulsive? Let us find out. When you have Q1 positive and Q2 also positive, then positive into positive will be positive, that is greater than 0. If you have Q1 negative, Q2 also negative, then minus into minus will become plus, that is greater than 0. So from this given data, we can say, from this given information, we can say both the charges might be either positive or both the charges might be negative. When both the charges are either positive or both of them are negative, means you can say given charges are like charges, and you know very simple basic fact, like charges always repel each other. So the type of electric force between these 2 point charges must be repulsive. So answer is repulsive force. But if the information given to you is opposite to this, not greater than 0, but suppose less than 0, it means to say if Q1 is positive, then Q2 is negative, then plus minus will be minus, that is less than 0. If Q1 is negative, then Q2 will be positive. So if Q1 into Q2 is less than 0, negative, then it is implied that one charge is positive, another is negative, means they are unlike charges, and unlike charges always attract each other. Okay, so at that time answer will be attractive force. Right now answer is repulsive force, because Q1 into Q2 is greater than 0. Okay. Read now number 11. Read it? Come on. Electric flux linked with any closed surface is, according to Gauss law, sigma q upon epsilon 0. Summation of algebraic summation of charges enclosed by considered Gaussian surface is given to you right now, 8.85 into 10 raised to minus 8 coulomb. only single charge is given to you, and divided by epsilon 0, permittivity of vacuum 8.85 into 10 raised to minus 12 coulomb square upon Newton meter square. Simplify this, answer is 10 raised to 4. SI unit of electric flux, come on, Newton meter square upon coulomb, Newton meter square upon coulomb. One additional tail ender question is given to you in the same question. Look, that if we make the radius of enclosing spherical surface double, then what will be electric flux? Electric flux will not change, because surrounding to this given charge, whether you consider this small spherical surface or big spherical surface, the charge enclosed by the closed surface remains same. And when this charge remains same, epsilon 0 is constant, sigma q also remains same, then naturally electric flux will remain same. Remember, for a given charge, the electric flux does not depend on the volume and shape of the enclosing surface. Volume and shape of enclosing surface may change, but as long as inside charge remains same, you will have same amount of electric flux. Got it? Fine. Now, we begin with the section E. In that section E, I am going to include very important all exercise numerical. I will give the symbol EN. Remember the symbol for illustrative numerical, IN. IN means illustrative numericals, which are given solved examples in the textbook, but these are now exercise numericals, correct? Fine. Now, just kindly read the statement of first exercise numerical, EN1, first exercise numerical. Read it? Look. Coulombian force exerted between two charges, one is QA, another is QB, separated by distance D, is, according to Coulomb's law, F equals to K QA into QB upon D square. Fine. Now what is done? Sphere A is brought in physical contact with another chargeless identical sphere C and then separated. I told you, whenever identical bodies are kept in physical contact and then after they are separated, equal amount of charge on both the bodies will be summation divided by 2. What is the charge on sphere A? It is QA. Charge on sphere C, initially it was chargeless, so charge is 0 divided by 2, summation divided by 2. So now it is QA upon 2, same amount of electric charge spheres A and C will have in their final condition after separation. Now sphere B is brought in contact with another identical chargeless sphere D and then after they are separated. So again equal amount of charge on both the spheres B and D would be summation divided by 2, correct? So this is QB upon 2 and that is the amount of charge present on the surfaces of spheres B and D in the final condition. That's why I am putting dash. Now QA dash is this much, QB dash is this much, and now spheres A and B are kept at half of earlier distance. Then what is the new value of Coulombian force? Let it be F dash. Then according to Coulomb's law, it is K QA dash QB dash upon D dash square, correct? This K as it is. What is QA dash? QA dash is QA upon 2, correct? QA upon 2. QB dash is QB upon 2, QB upon 2 divided by D dash square. What is D dash? Final distance between two spheres A and B. That is what they are given in the statement, half of earlier distance. Earlier distance was D, now it is D by 2 and its square, correct? So now tell me, 1 upon 2 square will be 1 upon 4. Here also 1 upon 2 to the 4, 1 upon 4 upon 1 upon 4, that is 1. So now it is K QA QB upon D square, K QA QB upon D square, which is nothing but K QA QB upon D square is nothing but F. So this is nothing but F. So in this case, new Coulombian force will be same as earlier Coulombian force magnitude wise, okay? Come on my dears, we proceed further in the exercise numericals of chapter number 1. Last time we had finished the first numerical from the exercise. Today we go ahead, kindly read the statement of second exercise numerical. You must have remembered I am giving this symbol En for exercise numerical. Okay. Kindly read the statement of number 2. Come on, have you read it? Look, I told you to remember one formula in such conditions. What was that formula? Tan theta equals to Fe upon mg. Tan theta equals to Fe upon mg. When the whole system is lying in the medium of air or in vacuum, at that time this equation you can apply, tan theta equals to Fe upon mg. Tell me, when you need to apply this equation, if you have two identical spheres having equal charge and suspended with the help of two equally long strings from the same point of suspension, then because of identical charge on both the identical spheres, when they repel each other, finally in the equilibrium condition, when the angle between two strings is becoming 2 theta, and then you had this equation obtained. In that case, what was that angle theta at that time? The total angle between two strings, it was 2 theta, but this theta means it is angle made by one string with the vertical, correct? Angle made by either string with the vertical, if it is theta, then you know what is Fe? It is electric force exerted by one charged sphere on another identically charged sphere. And what is mg? It is weight of one sphere. Got it? Fine. Now tell me, what are you doing now? According to the statement, the whole system is now immersed in some other liquid. Right now it is kerosene. Okay? In the examination you might be given some other liquid. At present it is kerosene. In short, now the whole system is taken from air to the liquid. Okay? When you immerse entire system in the liquid, now you require to make some changes in this equation. Look at the changes. Instead of Fe, I am putting Fe dash, correct? Because the electric force exerted between two charges when they are separated by given distance, it certainly depends on type of medium. Earlier the medium was air, now the medium is kerosene. Because there is a change of type of medium, you can say Coulombian force will change. Instead of Fe, I am writing Fe dash. Now tell me, earlier what was this mg? It was effective weight of the body in the medium of air. But now the same sphere is not suspended in air, it is immersed in liquid. At that time what will happen? That liquid will exert some buoyant force which is always in vertically upward direction. And what was the formula for buoyant force? As you have studied in 11th standard, that buoyant force was given by this formula, m0g. m0g. What is m0? Mass of the liquid displaced by completely immersed part of the sphere, correct? Mass of the liquid displaced by completely immersed sphere, that mass is m0. Fine. And m0g is the weight of the liquid displaced by immersed part of the sphere, correct? Now tell me, for that sphere which is immersed inside the kerosene, the downward gravitational force is mg, upward buoyant force is m0g. So now effective weight in downward direction is mg minus m0g. mg minus m0g. Why you are taking minus? Because of opposite direction. That's why I am putting here effective weight, which is mg minus m0g. Correct? And why here also theta and here also theta? They have said in the statement that though we keep the whole system inside the kerosene, then also the angle between both the strings remains unchanged. Earlier also that angle, total angle between two strings was 2 theta, now also it is 2 theta. So whatever was this angle theta, that is angle made by either string with the vertical, same angle is this theta also, correct? Fine. Now tell me, have you remembered when you are keeping two charges at a given distance, instead of vacuum or air, if you keep it in a dielectric medium having dielectric constant capital K, then electric force gets reduced to kth part. It gets reduced to kth part. That's why this new Coulombian force is kth part of initial Coulombian force. Initially it was Fe, now new force Fe dash has become kth part, or you can say 1 upon k times Fe, 1 upon k times Fe. So just apply this formula. Instead of Fe dash, what you will write now? Fe upon k, Fe upon k. Mind well, this is capital K called dielectric constant. Come on, replace Fe dash by Fe upon k. Replace this Fe dash by Fe upon k, Fe upon k, correct? This denominator as it is. Got it? Fine. And now when you compare these two equations, you can see left hand sides are equal. When left hand sides are equal, right hand sides have to be equal. So this will be equal to this. That is what I have written here. Come on. Fe upon mg equals to Fe upon k into mg minus m0g. Fe upon k into mg minus m0g. Correct? Simply equate the right hand sides. Now Fe will cancel. Correct? Now take this part over here, take this part over here. You will get k into mg minus m0g equals to mg. Correct? Now this capital K as it is. What is mass? Mass is volume into density. Mass is volume into density. But this is the mass of the sphere. That's why this rho is density of sphere. G as it is. Minus m0. What is m0? Mass. But again mass you can write volume into density. But this m0 is the mass of liquid displaced by immersed part of the sphere. Because this is mass of liquid, I should write here density of liquid, that is rho 0. Right now it is density of kerosene. And what about V? Why you are writing same volume here? Because when the sphere is immersed completely inside the kerosene, then volume of kerosene displaced by completely immersed sphere and the volume of sphere itself, both the volumes will be equal. When the sphere is immersed completely inside the liquid, then volume of liquid displaced by immersed sphere and the volume of sphere itself, both will be equal. So when you write a V here, here also you must write the same volume, that is V only. Okay, fine. Now G as it is, and M is again mass of the sphere. Mass is volume into density. But because this is mass of the sphere, here I am writing rho, which is density of sphere. And now throughout the equation, what you can cancel? V into G, V into G, V into G, you can cancel throughout the equation. What is left from here? K into rho minus rho 0, and that equals to rho. Correct? Now find out K. Come on, transfer this part in the denominator. Rho upon rho minus rho 0. Rho upon rho minus rho 0. Okay? I just appeal everybody to remember this formula, because in your examination pattern they are going to ask only MCQs. So at that time you will be short of time. Every time in the examination you will be finding that time is too short. In that case you will not have any time to think for such a long understanding, such a long explanation, you will not recall. Then better you remember this formula directly. Correct? When the angle between two sinks remains same, though we take the system from air to another liquid, at that time you can definitely apply this formula. Okay? Come on my dears, you please remember this formula. It will be very much helpful to you just to find out the answer very quickly. K equals to rho upon rho minus rho 0. What is capital K? Dielectric constant of given liquid. What is rho? Density of material of the sphere. What is rho 0? Density of liquid medium, which is right now kerosene. Come on. Here dielectric constant for kerosene they have given 2. Come on, rho is the density of material of sphere which we require to find out. Keep rho as it is. And what about rho 0? Density of liquid, which is right now kerosene. They have given in the statement 800 kilogram upon meter cube. Just put up the value of rho 0, which is 800 kilogram upon meter cube. Simplify value of rho from this, it comes out to be 1600 kilogram upon meter cube. Okay. Please remember this formula, okay? K equals to rho upon rho minus rho 0. Got it? Dielectric constant is always positive, okay? Fine. Now kindly read the statement of exercise numerical number 3. Have you read it? Look. We have one equilateral triangle, say A, B, C, having side length 5 centimeter. If you convert into meter, 5 upon 100, that is 0.05 meter. All the three sides have same measurement, 0.05 meter. Okay? Then we have 3 point charges located at points A, B and C. They are respectively, they have given 0.5 microcoulomb. 0.5 microcoulomb means 0.5 into 10 raised to minus 6 coulomb. Correct? 1 microcoulomb is 10 raised to minus 6 coulomb. But 0.5 into 10 raised to minus 6, that you can write as 5 into 10 raised to minus 7, that many coulomb. Correct? Let it be first point charge Q1. Fine. Second point charge placed at point B, they have given minus 0.25 microcoulomb. But minus 0.25 microcoulomb, if you convert into coulomb, that is minus 0.25 into 10 raised to minus 6 coulomb, that is minus 2.5 into 10 raised to minus 7 coulomb. Correct? Fine. What about third point charge? That they have given 0.1 microcoulomb. That is 0.1 into 10 raised to minus 6 coulomb. That is 10 raised to minus 7 coulomb. 10 raised to minus 7 coulomb. Let it be Q3. Correct? Now tell me, because you have taken here origin of the coordinate system, the position vector of this first charge will have coordinates 0, 0. Position vector for first charge, we just show it by symbol vector R1. And position vector means coordinates of a given point. Coordinates of origin are 0, 0. Correct? We are taking the distribution of these charges into a plane, that is 2-dimensional space. That's why we are mentioning only 2 coordinates. Okay? Fine. Now, what about position of second charge? Let it be shown by symbol vector R2. That is position vector of second charge. For this very point, its x coordinate is this much, which is 0.05 meter. Correct? And so far y coordinate is concerned, for any point on x axis, y coordinate will be 0. Correct? Now, where is this charge? It is in the first quadrant. Suppose its position has position vector, vector R3. Now, position vector of any point means coordinates of that point. If you want to find out coordinates of this very position, then remember, if this is R, suppose this distance is R, and if this angle is theta, then coordinates of this point R, remember R cos theta, comma R sin theta. R cos theta, comma R sin theta. Now tell me, instead of R, this side length, you know it is 0.05 meter, 0.05 meter, correct? Into cos theta, theta for an equilateral triangle, theta, each angle theta is same, it is 60 degree each. So R cos theta, R is 0.05, cos theta, theta is 60 degree, correct? Comma, y coordinate is R sin theta, R is 0.05, sin theta is 60 degree. Simple? Fine. Now cos 60 degree is nothing but sin 30 degree, which is 1 by 2. 1 by 2 into 0.05, that is 0.025. Got it? And here sin 60 degree means root 3 by 2. 0.05 upon 2, that is 0.025 into root 3, that many meter. Correct? Fine. Now what have they asked here? Find out resultant Coulombian force exerted on a point charge located at point C. Located at point C is the third charge, that is Q3. So in short, we want to find out resultant Coulombian force exerted on third charge. Come on, this is positive, this also is positive, this positive charge will repel this positive charge this way. And you know direction of Coulombian force is always align along the line joining the two charges. So direction of this force vector will be along the line joining these two charges this way, and it is repulsive force. Okay, it is repulsive force exerted on third charge by first charge. But now this is positive, but this charge is negative. This negative charge will attract this positive charge this way. Correct? And it is the attractive force exerted on third charge by second charge. Exerted on third charge by second charge. That's why I am giving the symbol vector F32. Okay? Now, if you can find out these two force vectors and if you add them, then naturally you get resultant force exerted on third charge. Correct? So, mathematically vector F3 equals to vector F31 plus vector F32. This is according to principle of superposition. Resultant force exerted, resultant Coulombian force exerted on any charge is just equal to vector addition of resultant independent Coulombian forces exerted on that charge by rest of the charges. Okay, I repeat, resultant Coulombian force exerted on any point charge is just equal to vector addition of Coulombian forces exerted by rest of the charges on that charge independently. Correct? Fine. Now, vector F31, can you recall vectorial form of Coulomb's law? Can you recall? What was that? Vector Fij, how much it was? It was equal to K Qi Qj upon mod of vector Ri minus vector Rj whole cube into vector Ri minus vector Rj. Similarly, come on, instead of I you may write 3, instead of j you may write 1. Then you get vector F31 like this, K Q3 Q1 upon mod of vector R3 minus vector R1 whole cube into vector R3 minus vector R1. I told you to maintain the order. You see the order 3 1 3 1 3 1 3 1. Correct? Now come on, plus vector F32, that is Coulombian force exerted on third charge by second charge. Come on, according to the same vectorial form, come on, vector F32 will be K Q3 Q2 upon mod of vector R3 minus vector R2 whole cube into vector R3 minus vector R2. Here it is, K Q3 Q2 upon mod of vector R3 minus vector R2 whole cube into vector R3 minus vector R2. Just check the order, come on, 3 2 3 2 3 2 3 2. Correct? Now tell me, from this right hand side, which part you can take common? K Q3, K Q3. You can take common. Just take it common, K Q3. Inside the bracket, come on, now left is Q1 into vector R3 minus vector R1 divided by mod of vector R3 minus vector R1 whole cube plus K into Q3 has gone out. Left inside the bracket is Q2 into vector R3 minus vector R2 upon mod of vector R3 minus vector R2 whole cube. Correct? Now here we require vector R3 minus vector R1 as well as its magnitude. We also require vector R3 minus vector R2 and also its magnitude. Correct? So let us find out all these values first of all, and then at a time we will substitute all the values. Okay? Vector R3 minus vector R1 I require. This is vector R3. This is vector R1. Then you require vector R3 minus vector R1. How would you take subtraction of two vectors? You have to take subtraction of respective coordinates. X coordinate should be subtracted from x coordinate only. Y coordinate should be subtracted from y coordinate only, like that. Come on, you want vector R3 minus vector R1. So it is this minus this. So it is this minus this. Come on, 0.025 minus 0, that is 0.025. Come on, 0.025 root 3 minus 0, that is 0.025 root 3. Correct? That many meter. I have not written the unit here, but that many meter. Okay? Now you want modulus of it. Modulus of it. Okay? How to get modulus of this? Come on. Under root of square of this plus square of this. Correct? That answer is 0.05 meter. but I am showing you very easy way. You want modulus of this, correct? You may find out under root of square of this plus square of this, correct? But I am showing you easy way. When you take modulus of this, ultimately what will it give to you? It will give distance between first and third charge. Distance between first and third charge. This is first charge, this is third charge. Distance between them is the side length for this equilateral triangle, which is 0.05 meter. That's why I am writing directly 0.05 meter, correct? Now I require vector R3 minus vector R2 also. So let me find it out. Vector R3 minus vector R2. This is vector R3, this is vector R2. Now I want this minus this, that is this minus this. 0.025 minus 0.05, that is minus 0.025, comma this minus 0, that is this only, na? 0.025 root 3, 0.025 root 3, got it? And now I require modulus of this. And when you take modulus of this, just now I told you, it will give you distance between second and third charge. Distance between second and third charge. This is second charge, this is third charge. Distance between them is nothing but side length for this equilateral triangle, which is 0.05 meter. 0.05 meter, correct? You may find it using that formula, square root of summation of squares of mutually perpendicular components, that is under root of, come on, square of this plus square of this. It will also come out to be same 0.05 meter. Okay, I have shown the easiest way. Now put up all the values. K, it is 9 into 10 raised to 9 Newton meter square upon Coulomb square. This is proportionality constant small k coming in Coulomb's law. Have you remembered this value? 9 into 10 raised to 9 Newton meter square upon Coulomb square. What about Q3? Q3 is 10 raised to minus 7 Coulomb. 10 raised to minus 7 Coulomb. Into bracket Q1. Q1 is 5 into 10 raised to minus 7. 5 into 10 raised to minus 7. Into vector R3 minus vector R1. Vector R3 minus vector R1, same vector I am writing here, same vector. You can just check it. 0.025, comma 0.025 root 3. 0.025, comma 0.025 root 3. Correct? Divided by, come on, cube of modulus of vector R3 minus vector R1. Come on, cube of this means cube of this. Correct? So 0.05, it's a cube. Plus, come on, Q2. Q2 is how much? Minus 2.5 into 10 raised to minus 7. Minus 2.5 into 10 raised to minus 7 into vector R3 minus vector R2. Vector R3 minus vector R2 is this. And same I have written here. Same. You can check it. Come on. Minus 0.025. Minus 0.025. Comma 0.025 root 3. Comma 0.025 root 3. Correct? Divided by cube of modulus of vector R3 minus vector R2. Come on, cube of this means cube of this. That's why I am writing here 0.05, it's a cube. Correct? Fine. Please be very careful while putting the values. By chance in hurry, you are putting wrong values here. Naturally, answer will be 100% wrong. Correct? So don't do that. From the step onwards which you want to simplify further, that step you must write very carefully. Okay, check it once more. Okay, and then proceed further. Now tell me 9 into 10 raised to 9 as it is, 10 raised to minus 7 as it is. From the inside part, I am taking a product common. Which product? 10 raised to minus 7. 10 raised to minus 7 I can take common. Then 0.025, 0.025, 0.025, 0.025. That also I can take common. So I am taking 10 raised to minus 7 also common and 0.025 also common. Then tell me what is left inside the bracket. This 0.025 and 10 raised to minus 7 has gone out. Now left is 5 into 1, that is 5. And here 5 into root 3. 5 into root 3. Because this 0.025 and 10 raised to minus 7 has gone out. Now here 0.025 and 10 raised to minus 7 has gone out. Minus 2.5 into minus 1, that is plus 2.5, comma, this 0.025, 10 raised to minus 7 has gone out. Now left is minus 2.5 into root 3, minus 2.5 into root 3, correct? And in the denominator 0.05 cube, 0.05 cube, that also from LCM you can take out. Come on, it is taken out, 0.05 cube, correct? Fine. Now simplify. 25 9s are 225. What about power to the base 10? I am showing you. Here it is 25 into 10 raised to minus 3, minus 3 minus 7, minus 10, minus 10 minus 7, minus 17, 9 minus 17, that is 10 raised to minus 8. Okay. This is 5 cube, 5 cube is 125, and 10 raised to minus 2 cube will be 10 raised to minus 6. And this 5 plus 2.5, it is 7.5. Then this minus this, root 3 can be taken common. 5 minus 2.5, that is 2.5 into root 3. Okay. Now simplify. 10 raised to minus 8 upon 10 raised to minus 6. So left inside the numerator is 10 raised to minus 2. Now 25 9s are 225. 25 5s are 125. So it is 9 upon 5. 9 upon 5. And from this 2, I have taken 2.5 common. If you take 2.5 out from here, left inside the bracket is 3, 2.5 has gone out here, then left inside the bracket here it is root 3. And now 2.5 into 9 into 10 raised to minus 2 upon 5, final value is 0.045. This 3 comma root 3 as it is, and that many Newton, because all the values we have placed in SI unit. Naturally SI unit of Colombian force is Newton. This will give you resultant Colombian force exerted on third point charge, which is placed at point C, which they have asked in the statement, correct? So your answer we have obtained here. I mean the example is over at this step. But let us see some extra note. Suppose they ask magnitude of this Colombian force, how will you find out? I am showing you very simple. First of all, you take this inside, this into 3, answer is 0.135, comma, this into root 3 is 1.732, multiplied by this, answer is 0.07794, okay. Now mesh this with x component, mesh this with y component. These are x and y components of F3, that's why I am putting the symbol F3x, comma, F3y, correct. And now tell me, you want magnitude of this, so it is F3, it should be equal to square root of summation of squares of mutually perpendicular components, that is under root of F3x square plus F3y square. Come on, square of this plus square of this, and then you can find out it's a square root, that will be magnitude of vector F3, got it? If they ask, then you can find it. What about direction? In order to find out direction of any vector, you should find out angle made by that vector with positive x-axis. If that angle is theta, then there is a famous formula you have studied in 11th standard. Angle of directivity is given by theta, then tan theta is y component divided by x component of a given vector. Y component of F3 is F3y divided by x component of F3, it is F3x. Because this is F3y, this is F3x, you can take the ratio of this to this, and then that will be giving you value of tan theta. Once you know value of tan theta, then using table of natural tangents in the log table, you can find out theta, right? But all this process you will do only when if they ask, okay? Right now, Colombian force is asked, that is what we have found out in the vectorial form this way, got it?